Hello everyone and thank you very much for joining me in this tutorial. Hello everyone and thank you very much for joining me in this tutorial. In this one, we are going to see how we can deploy a machine learning model, okay, through Kubernetes, Minikube, Docker on a Linux server, and how can we access it and get the response from it. Okay, so all that will be covered in this tutorial. Stay tuned with me and don't miss any part of this video. Don't skip anything. Okay, try to understand each and every step right from the beginning till the end. Watch it completely, okay, so that you can understand it well. So here, if you see, I am passing this as an input. So these are the features which I'm passing as an input in the form of a JSON. Okay, now if I will do the enter, this image or the model on which I've trained this image is returning this as an output. Okay, let me just change it to something like this. Now it has returned 0. So currently the model can be accessed through a Flask application on port number 5000. Okay, now how it happened and how I was able to put it on the server inside the Docker containers and all, that is what I'm going to show it to you, okay, in this video. Now the first thing that you have to do is you have to create a Linux server on AWS, or even if you're using Microsoft Azure or GCP, you can easily create an Linux server, okay, and then once you're done with that, you can use MobaXterm fine for entering into the server. So there is a PEM key, right, which you generate and then you log in into the server. Now, after you log in, the first thing that you have to do is updating the packages of the server. Okay, so this is a command. You can simply fire it and your package will get updated. Second thing you have to do is install the Docker on your Linux server. So these are the commands with the help of which you can easily do it. Fire these commands one by one and your Docker will be installed on your device. Once you're done with installing the Docker, what you can do is you can simply run this command to check if the Docker has installed successfully or not. So if you get an output like this, it means that the Docker is now there on your server. Second thing that comes is installing the Kubernetes tools. So there are two tools that you will have to use for deploying this model or a machine learning model on Kubernetes, and that is kubectl and Minikube. These are the four steps you can use for installing kubectl and also for checking the version of kubectl. So this is what I did first. After that, I did the chmod and I moved this kubectl into this bin directory of local of my user. Now let me just show you the kubectl version of mine. So it is 30.1. Okay. Now the next thing is installing Minikube. These are the 3 steps again with the help of which you can install Minikube and you can move it to the bin directory where the Kubernetes kubectl tool is present. Okay, once you're done with installing these 2 things, you can start your Minikube. Fine, this is a command with the help of which you can do it. Okay, now once your Minikube starts, you can check the nodes and the pods. At present, if you see, I'm getting this node here. Okay, because there is one Flask application running inside the Kubernetes pod, and that is this one. Okay, this is the model file. Okay, and these are the things which are currently running. Okay, these are the pods. Now initially you will not get anything. For you it will be a blank screen, or you will not get any output from this because you have just now installed Minikube and kubectl. There is no pod or node running on your server, correct? But for me it is showing all these things because before shooting this video I've already done this setup, and these are just the steps which I'm showing you. Once you're done with installing these 2 things and setting up Minikube and kubectl on your server, you have to create this file structure. There is this ml-deploy name directory that you have to create, and you can create it anywhere. Fine, I've created it inside this home directory of my user, and inside this ml-deploy I created this file, then this one, Dockerfile, right, requirements, service.yaml, train-model.py. Here we are using this load iris. It's a data set which you get by default from Versicolor, and then there is this random forest classifier algorithm that we're using here, and using this we are simply implementing it on this data set and creating a model out of it. Okay, I've just deleted the model which is outside the Kubernetes environment. Okay, how I created that model.pkl file. So you need to install these libraries first. Either you can fire this command directly, or else you can fire the requirements.txt command. Okay, so all the libraries which I require for creating the model are already there. Now I'm going to simply do pip, so Python pre-train and invalid syntax. Okay, no problem. Let me just remove it from here and put it over here. It hasn't got saved. So as you can see, now if I'll come back in the directory, the model.pkl file is it. So this is how you can create the model file. Now the next thing that comes is, let me just do this again. Now the next thing that comes is, so this is about the model which I've written here. It's the iris flower species model, this one, load iris, and using this you can find out the class names. So if you're passing inputs like this, okay, you're passing inputs like this, what will be the output? If you'll pass this, what will be the output? All that. Fine. Now the next thing that comes is create a Flask API. So this is an app.py file which you have to create here inside the same directory, and there you'll have to put this complete code. So here if you see, we're using this model.pkl, and then we have created a simple route predict, okay, to which we will pass the JSON format data, and this will do the prediction for us. Next thing that you have to do is create a Dockerfile inside which you can put all these things, and then comes the deployment.yaml file. Okay, so here you have to name the image. Okay, and then on which port would you like to run the application? So it is port 5000. That's the reason I've written 5000 here. Now comes the service.yaml. Service.yaml is to tell the cluster on which port you're going to expose the services to the end user. So it is port number 30,036, and we have mapped it to 5000 here. Okay, so this is a complete mapping. And then what is the next thing? Okay, so once you're done with creating all these files, the next thing that you have to do is, so all the code, everything is there in this file. You can pick it up from here. You don't need to search it over the internet. Build and deploy steps. So you have to create the ML-model named image first. But before that, you need to connect your Docker CLI with Minikube's Docker. Correct. So that for that you'll have to fire this command. Okay, make sure you are inside this ML-deploy directory you have created. Then you can build your image like this. For me, it didn't took that much of time because I already did that earlier. Now comes the application of this deployment.yaml. Just apply it, and then apply the services.yaml, and here you will get your pods as well as you will get the services. Okay, so we have the pods and everything required for accessing the application done. Now comes the starting of the ML model. Okay, so we have restarted this application, and now you're going to expose it. So 5000, we are exposing it on port number 80. Let me check if it is working or not. So yes, I'm getting the output. So see, it is working. Fine. Now, once you're done with all these things, if you want to clean it up all, just fire these commands. Sorry. Okay, I've deleted it. I'm going to delete this service.yaml also. And let me just stop the Minikube. Fine. So all these things you can do for cleaning up your server. Fine. That's how you can deploy a machine learning model through Kubernetes, on a server, and you can also expose it to your services. That is it from my side in this lecture. I hope you guys enjoyed it. Bye bye. Take care and have a great day, guys.